Good day, everyone. This is going to be a quick educative video on how to use FEHT, finite element heat transfer, to simulate a real world problem. So, for an example, sometimes we have tankers spilling oils on the pavement, and these oils can seep into the groundwater. So, to estimate the contamination or the rate of contamination, you usually do this using numerical tools. So there are different aspects of this. We just be focusing on the water flow aspect of it. So to simulate the water flow of this, of like about 2 meters from the pavement surface into the perforated storm pipe, the key things we need to know is that first we need to know the area of influence in terms of vertically and laterally. So there's a rule of thumb that for the lateral extent, at least you must do like 2 times the vertical influence. So, and for the vertical influence, some people you might do like just 3 times 2 first. That's going to be 6. So you measure 6 from this point. You are seeing my cursor downward. So it's going to be 6 plus 2. That's 8 meters. So I might use 8 meters for the vertical extent, and 3 times 8 is now be 24 meters for the lateral extent to the left and to the right, making 24 plus 24, 48. But it's usually better for you to simulate a bigger domain. So I'll be simulating a bigger domain. So I'll be adding 48 to this 2 meter, which is going to be like 50-meter deep. Then I'm going to do at least 2 times 50, which is 100. So we're having 100 to this side and we're having 100 to this side. So we're having like 200 by 50. Or we can now increase it to 300 by 50, and you can check the percentage difference before you can go ahead and say it is okay for your domain. Let me say that again. After trying out the first domain, you can do a bigger domain. For example, I'll be trying out 200 by 50. You can now do like 300 by 50 and compare the output for you to know if there's much difference between the first domain and the second domain. Usually a percentage difference of about 5 to 10% is okay for you to say, okay, the domain you are using is fine. So we proceed to fit now. So in fit, the first thing is to change the subject to porous media flow. And the second thing is to go to the setup and you do your scaling. For me, since it's going to be like a big domain, I'm going to be using like 1 meter for about, let me say, 4 centimeter. And I'm going to be simulating this in axisymmetric. That means whatever value I'm getting, I will have to multiply it by 2 for me to get the exact value. So I would like to start from here because I'm doing 50. Okay, why is giving me about 100 here? And I'm getting about 150. Yeah. So in that case, I would like for me to start from 0 and for me to be able to see the 0 very well. Okay, I can see it here. So I can click draw outline. So I'm starting from x of 20 and y of 0. So x of 20 and y of 0. So that means for the lateral extent of 200 meter in axisymmetry, which should be 100. Since I'm starting from 20, I'll be looking for 120. So this is 120 and my y of 50. So 50 is going to be at the center. And I'm going to come here. I just want to make it to be at least an approximate of what I'm looking for. Yeah. So the next thing is to add the properties of the soil. So I'm going to choose clay. Let me confirm from what we are trying to simulate. So let's assume the subgrid has an hydraulic conductivity of 1 times 10 raised to the power minus 3 centimeter per second. So in this case, this is centimeter per second from our question. I'm going to make it in meters, so it's now minus 8 here, minus 8. Okay, the next thing is to add my boundary condition. So there's no flow from here. All our flow is coming from the surface of the pavement. So the head is going to be 0 flux at this point, and down here too, it's going to be 0 flux. And Since it's axisymmetry, it's going to be zero flux here too. Zero flux. And here, since the water is flowing based on the influence of that height, so the head is going to be y, which is 50 meter. Okay, so the next thing for me to be able to mesh, I need to start adding some element lines. So I would like to save first. Save as save flow. So for me to start the meshing process, I'm going to pick element line. And I can reduce the mesh as much as I want. So I'm going to reduce the mesh for it to be a very fine mesh. So remember from our question, we have our perforated located at about 2 meters below the surface. So for me to simulate this effect that water is entering into this storm water pipe, I'm going to make the pressure head at this place to be 0. So if I want to make the pressure head at that location to be 0, I can come to my display. So since my total head is 50, I'm looking for 48. So this 49, this 48.4, this 47. If I reduce the mesh, I should be able to get something close to 48 exactly. So this is 48. So at 48, I'm going to give it a total height of 48 or the y. It's telling me that if the total height is the height of that location, that means the prayer height is 0 at that point. So I'm going to click OK. Then I'm going to go to calculate. I'm going to continue. So it's done calculating. So the first thing we can view is we can try to view the volumetric flow. So the volumetric flow is 2 times 10 raised to the power minus 7 meter cube per second meter. And we can also view the volumetric flux. So it's showing us that water is coming and is entering this point, which is the stormwater pipe. Also, we can view the head contour. Okay, so you can see the air contour that most of it dominates the right part here, showing that the water is flowing into the stormwater pipe here. So what I want us to note here is the volumetric flow. So checking the volumetric flow again, our volumetric flow is 2 times 10 raised to the power minus 7, but we need to note that we simulated an axisymmetry condition. So the actual flow is going to be 2 multiplied by this, which is 4 times 10 raised to the power minus 7. I want us to note this. Remember, 4 times 10 raised to the power minus 7, and we simulated 100 by 50. In axisymmetry and in a full domain, it's going to be 200 by 50. We are going to try same thing using RS2 and compare the flow into the storm water pipe. Thank you for watching. And to add